Hi, Guy Moxey from Wolfspeed Power, and welcome to Bodo's Wide Bandgap event, and more specifically, the electrification of everything with Wolfspeed Silicon Carbide, where we'll discuss technology, development, and evolution, and how it will shape the future of power devices across the continuum. Technology is a big, broad word. How many times have we heard we have the best technology? Well, here at Wolfspeed, we use technology in several ways, all key for the evolution of silicon carbide. So first and foremost, let's talk about technology for enablement. We know over the last several years that silicon carbide has enabled such end systems as renewable energy, solar, fast charging, fast DC charging, that is, for electrification of vehicles, and of course the stable power supply, enterprise power supply. But let's look at enablement for the future with Wolfspeed Silicon Carbide. What applications and end systems are triggering into the need for silicon carbide because of its performance, its power density, its efficiency, its overall lower system cost? Electrification of everything is a broad term, but it can range from obviously vehicles that move on roads and roadsides or on the land, not just restricting it to passenger vehicles, but also the electrification of the skies, whether that's the more electric aircraft in the traditional sense or more eVTOL, vertical takeoff, e-taxis. Then obviously with a higher voltage, higher power, higher ampacity of silicon carbide being achieved today, we can turn more electrical machines, as 40% of the world's energy goes through in a rotating machine. We can tie to the grid in a more efficient way with higher voltage silicon carbide modules, right through to facilitating higher overall system efficiency standards and legislation. So technology at Wolfspeed starts with technology for enablement. Let's now talk about Wolfspeed using technology, silicon carbide technology, for carbon neutrality, something that we are all striving towards, whether it's as an individual, as a corporation, as a region, as a country. And it is critical that we achieve these goals. So ESOI, energy saved on energy invested, is an important way of looking at overall carbon neutrality. And with regard to silicon carbide, energy saved over a lifetime of use divided by the marginal energy cost of producing a silicon carbide transistor versus something in silicon. Or basically you can distill it down to every kilowatt hour of energy invested to produce a Wolfspeed power device, a chip or a package device, saves society XXX kilowatt hours over its lifetime of use. Here, for example, we have worked over a 50 kilowatt PV string system. And obviously this can be deployed in various parts of the world, and it frequently is. So here we actually do a realistic workover or calculation. Depends on region, more sun, less sun. And in a region where there is abundant sunshine, something like Phoenix, Arizona, we have a 77-to-1 ESOI. So every 1 kilowatt hour invested to make a Wolfspeed chip gives you 77 kilowatt hours in return. Or actual fact, when you model that usage of that 50 kilowatt string system in Phoenix, Arizona, in actual fact, that comes out to 1,078 kilowatt hours per year of ESOI. Now moving to somewhere slightly less sunny, Albany, New York, 55-to-1. Still an incredible way of using silicon carbide technology for carbon neutrality. Now, moving to more familiar territory for most of us, using technology for performance. Here we're talking about our devices and how they lead the pack in not only things like voltage nodes, 600, 650, 900, 1000, 1200, 1700 volts, but also ampacity and packaging if it's discrete, optimization of certain subtle in-circuit parameters, body diode, threshold, for example, RDS on, lower RDS on over temperature is using technology for performance. In a die area, different metallizations, different die layouts, different aspect ratios to accommodate advanced packaging. And obviously then when you move to a module point of view, here we show our XM3, which is in the lucid air, the picture on the left. But more importantly, the XM3 has the highest ampacity per half bridge of any module in the industry per footprint. So using technology for performance. And then if we step to today and into tomorrow, taking silicon carbide up past and through the 1700 volt industrial recognized voltage nodes into 2 kV up to 20 kV and beyond. Here is just incredibly mind-boggling on performance. So 1.7 kV, 2.2 kV, 3.3 kV, 6.5 kV, 10 kV. Now with Wolfspeed silicon carbide, we have the voltage nodes and we have the ampacity to go along with it in these high power modules. And at that sort of mid voltage range, the transformation of the end system is incredible. IGBTs switching at hundreds of hertz, maybe 1 or 2 kilohertz, versus silicon carbide 2-level circuits switching at 20 kilohertz. And here you can see a 2 MVA grid-tied solar inverter system example at 1.7 kV at the lower voltage end, switching at 35 kilohertz. Up at the grid-tied higher voltage end using 10 kV product, switching at 7 kilohertz. So this is just a very clear and simple view of Wolfspeed using its silicon carbide technology for performance. And how else do we at Wolfspeed use our technology? For capacity. While others talk and think about 200mm wafers, we are achieving them. Back in 2015, we produced our first R&D grade 200mm substrate. Now, 7 years later, we are ramping to full production in the first, the largest, the only dedicated silicon carbide wafer fab with automotive grade 200mm finished wafers. That vertical supply chain supported by, there's more, the first, the largest, the only silicon carbide substrate foundry being created today in North Carolina. Wolfspeed using technology to supply the world with capacity for silicon carbide. And finally, Wolfspeed using its technology for the power continuum. I started off this brief discussion mentioning the power continuum. Here is a great visual showing the power continuum. Silicon carbide from a kilowatt or 2 in discretes, ranging through lower power modules with the Wolf packs into the highest power density modules, into industry standard recognizable BM3 modules, into the highest power density XM3 modules, and now accelerating into the megawatt scale with our mid voltage product. This covers the end systems that have triggered and keep continually triggering for silicon carbide in this multi-decade opportunity. Power scaling and products for the power continuum. This is how Wolfspeed uses its technologies, plural, in many different ways to enable silicon carbide for a better future. Thanks for listening. Bye-bye.